Our purpose here is to look at some types of problems that you can be asked in finding the volume of combination of figures. And notice that all you need to remember to do them is just the old three formulae. Let's go one by one. One is a direct addition. You're given some figure. This looks like the thing I used in chemistry lab, or at least I broke in chemistry lab. I think it's called a round bottom flask. So over here, as you see this, if you have to find the volume of this, you will notice that you can imagine it to be made of a sphere over here and a cylinder. You will approximate, of course, like you can imagine this to be a sphere given it's very small. And then you have to add the two volumes and you'll get the final volume. Over here, you can imagine it to be made of, that's right, one cylinder over here and two hemispheres, similar to what you may have done in surface areas. And that's the addition one. The other type that I feel, it's not exactly another type in the sense that you use a different method, but it's just something that you might see that looks different from this, where it's not added, but it's removed. So here a hemisphere has been removed from a cylinder. Here a cone has been removed from a box or a cuboid. And here maybe you're making a pen stand here, and here maybe you're making, a pond or something. And in this case, you have to find the volume of the bigger figure and then remove the volume of the smaller. And in this case, you will actually subtract because it's the amount of substance. So removing something here actually means subtracting the volume. You may remember that in surface area though, even if you're removing, this area will get added. But in volume, this will get removed. So in some sense, volume is a little bit more intuitive. Removing a volume leads to reduction. And then there is no concept of curved surface volume, total surface volume, none of that. Volume is just the amount of substance. So you don't even have to ask questions like, hey, should I include this bottom one or not? None of that. Because volume is just the amount of substance like I just said. So the other type that I feel is once you have mastered these two, you can do a little bit more with them. It's not new, but you'll be combining things. So here, for example, you'd be asked, what is this remaining area over here? And I've drawn it in a 2D way over here. What I mean is, let's say this is a cylinder and this is a cone and this is a hemisphere. You put this combination inside and ask how much area volume is left over here. And the way to do it is to find the volume of the hemisphere, find the volume of the cone, add the two, and then subtract that entire thing from the volume of the cylinder. And you can notice that this is a longer problem, but doesn't mean you need to know anything new to do it. Another way to make the problem longer, if not more difficult, is to give you many such. You take a body like this. These are like small little versions of this, and put many of them. So now you have to find the volume of one and then multiply it by whatever number there is. So these are all ways to make the problem slightly long. And to do all of these, the only formulae that you need to know are pi r square h for a cylinder, 1 by 3 pi r square h for a cone, basically 1/3 of a cylinder, and 4 by 3 pi r cubed for a sphere. So this is for a sphere, this is for a cone, and this is for your cylinder. And of course, I'm assuming that you are comfortable with length into breadth into height for finding the volume of a box or a cuboid like this.